So in this video I'm going to run through the answers to exercise 3 in 5.1 and in the first question I give you the electron configurations and I just ask you for the correct element. So there's two ways that you can do this and you should probably do them both just to make sure you're doing it right. First way is just add up the number of electrons and then find the atomic number on the periodic table. So I got 2, 4, 10, 12, 16 electrons. I go to my periodic table and I need to find an element with the atomic number of 16. Now remember, the atomic number is the smaller of the numbers. The smaller number on this periodic table is written here at the bottom. So I need to find an element with 16 as the atomic number, which is going to be sulfur. The other way that I can do this is using the position of the periodic table. So I know that it must be in period 3 because it's got 3 energy levels and it's a p block element with 4 p electrons. So if I go down to period 3, 1, 2, 3, and I look at my p block elements, which p block element has 4 p electrons? 1, 2, 3, 4, it's going to be sulfur. The next one, again, I'm going to do both ways. So 2, 4, 10, 12, 18, 28, 30, 31 electrons. So 31 electrons. I have it here. It's gallium. So gallium has an atomic number of 31. Checking its position, I see it must be in period 4 because there are 4 energy levels. And it must be a p block element with just 1 p electron. Period 1, 2, 3, 4, and gallium is my first p element in period 4. So it's got 1 p electron there, gallium. Next one, 2, 4, 10, 12, 18, 21, 23. So I'm looking for something with 23 electrons, which would be vanadium. Just want to double check. I've got 4 different energy levels, so it should be in period 4, and its highest occupied is 3d, and it's got 3d electrons. So I'm moving down to period 1, 2, 3, 4. I'm moving into the d block, and it should have 1, 2, 3 d electrons, making it vanadium. Next one, I've used one of the shortcuts. Okay, neon accounts for 10 electrons, so that means I've got 10 plus 2 is 12. The element with an atomic number of 12 is magnesium. Magnesium is in period 3 and it's in group 2, so it should have 2 electrons there in its outer shell and it's an S block element, so that all fits. Neon again is 10 and 2 is 12 and 5 is 17. The element with an atomic number 17 is chlorine. Chlorine is in period 1, 2, 3. It's a P block element and it's got 1, 2, 3, 4, 5 P electrons, which is what I've got here, 3p5 is my outer shell. Then I've got argon. Argon represents 18 electrons, so I've got 18 and 2 is 20 and 7 is 27. So my element with an atomic number of 27 is cobalt. But just to double check that I'm right, it's a D block element. It's got 7 D electrons. So if I go here, 1, 2, 3, 4, 5, 6, 7, cobalt is my seventh D element, so it should have 7 D electrons. So by doing both of those checks, you will be certain that you have got the right answer. So the second part of exercise 3, you were asked to write the electron configuration of some ions. Okay, so your first one you're asked to do is lithium plus. Okay, I go to lithium and I find out how many electrons lithium has. 3, but it's lithium plus. The plus tells me that lithium has lost 1 electron. So it had 3, it lost 1. That means that lithium plus has only got 2 electrons. To write the electronic configuration of something with 2 electrons, it's just going to be 1s2. Chlorine minus. So chlorine normally has 17 electrons, but the chloride ion has got a negative charge, the negative charge telling me it's gained 1 electron. So it had 17, it's gained 1, it's now got 18. So I've got 18 electrons to fill into orbitals. 1s2, 2s2, 2p6. That's 10 already done. I've got another 8 to go. After 2p comes 3s, and then 3p. That gives me 2, 4, 10, 12, 18, which is the correct number of electrons for a chloride ion. Next up, I've got Mg2+. Magnesium has 12 electrons. but because it's got a 2 plus charge, that tells me it's lost 2. So instead of having 12, it's now only got 10. So I'm writing the electron configuration for something with 10 electrons. I put 2 electrons in 1s, I put 2 electrons in 2s, I put 6 electrons in 2p, 2, 4, 10. They are my 10 electrons. The next two, vanadium and scandium, they are transition elements, and these you do need to pay a little bit more attention to. Vanadium normally has got 23 electrons. It has now got a 2 plus charge, which means vanadium has got 21 electrons in total that I need to assign, okay? But rather than just writing out my 21 electrons, all right, I'm actually going to write here what vanadium usually looks like when it's an atom, and then I'm going to work backwards. So when vanadium is an atom and it has 23 electrons in total, it's 1s2, 2s2, 2p6, there's my first 10, 3s2, 3p6, there's 18. I've got another 5 to go. I've got 3d, and then I've got 4s. I put 2 into my 4s because it's lower in energy, and that leaves me with 3 in 3d. So there are my 23 electrons. Now your vanadium 2 plus ion is going to lose 2 electrons. The last orbital that you filled was the 3d orbital. However, the first orbital you will empty is your 4s orbital. The reason for this is when occupied, the 3d actually becomes lower in energy than the 4s. You don't need to be able to explain it. All you need to know is that when you're writing the electron configuration of an atom, you fill the 4s before you're filling the 3d. When you're writing the electron configuration of a transition metal ion, then you are going to empty the 4s before emptying the 3d. So the 4s fills first, the 4s empties first. So if I've got 2 electrons to remove from vanadium, instead of taking them from 3d, I'm going to take them from 4s, and my electron configuration will look like this. 1s2, 2s2, 2p6, 3s2, 3p6, take them from 4s2, so I'm left with 3d3. You can write 4s0 if you want to, or just leave the 4s out completely. Okay, we're going to do the same process with scandium. So scandium normally has got 21 electrons. Okay, so normally it looks like this. 1s2, 2s2, 2p6, 3s2, 3p6, so that's 18 accounted for. I've got 3 more to go, 3d and 4s. 4s fills first, so I put 2 in there and 1 in 3d. When I have my 3 plus ion, I need to draw 3 less electrons. So instead of drawing 21, I'm only going to draw 18. So I'm going to start it off out as before. 2p6, 3s2, 3p6. Okay, I've got 3 electrons to take away. I'm going to empty the 4s first. I'm going to take 1 and 2 out there. Then I'm going to move to the 3d and remove the 3rd electron, and that's just going to leave me with what I've already got here. So I'm losing 3 electrons, 2 come out of the 4s, then 1 comes out of the 3d, and it leaves me with this. Okay, so with your transition, your d block elements, the 4s orbital fills first when you're writing the electron configuration of an atom, but it also empties first when you're writing the electron configuration of an ion. So take them out of the 4s before you take them out of the 3d. With your s and p block elements, it's much easier, okay? The orbital that fills last will then empty first. So it's kind of as you would expect.